So today we're going to go one step farther with graphing exponential functions. So instead of just looking at the actual exponential function and picking out the important information, we're going to use all that important information in order to create a graph of the function. So if we're looking at f of x equals 2 to the x, and we want to graph this function, the first thing we want to ask ourselves, is it growth or is it decay? If it's growth, that means our b is greater than 1. It's decay if b is less than 1. If it's growth, it's a graph that looks something like this. If it's decay, it starts off fast and ends up slow. So we want to know if it's growth or decay because that kind of gives us an idea of what the graph is going to look like before we start drawing. So I look over at my b value, and remember your b value is whatever's the base of your exponent. And since 2 is greater than 1, that tells me that I'm working with a growth function. So my function is going to be growth since my b value is greater than 1. After I decide if it's growth or decay, then I want to find my y-intercept, which just means plug in x equals 0, because anytime I'm working with my y-intercept, that means my graph is crossing the y-axis, so my x value has to be 0. So I just want to find f of 0. So I do replace my x value with 0. 2 to the 0 is just 1, which means my y-intercept is going to be 0, 1. And when I'm writing my y-intercept, I want to write it as a coordinate. Then I want to decide what my horizontal asymptote is. And remember, if we're looking just at like the general equation for a exponential function, the asymptote is whatever we're adding or subtracting at the end. This is our asymptote. And our asymptote is always going to be an equation because our asymptote is a line, an imaginary line that our graph can't cross over. So whenever we're writing out our asymptote, it's always going to be y equals, because y equals are our horizontal lines. And then we look and we say, okay, what are we adding to the end of our function? And we're not adding anything here. So it's really like saying plus 0. So since I'm really adding 0 to my function, my horizontal asymptote 0. So anytime I'm writing my horizontal asymptote, it's going to be y equals, and then I'm just looking for whatever number I'm adding to my function. After I get my y-intercept and my asymptote, I just want to plug in a couple other values for my function. And the reason I want to do that is if I go and look at what I've got so far, so if I went in and started to graph what I have so far, I don't have enough information yet to get a really good picture of the graph. I need a little bit more. So if I'm looking, I've got my x-axis and my y-axis. I know that it's a growth graph, which means its shape is going to be something like this. I know that I have the point 0, -1, so I can plot that point 0, 1. I also know that I have an asymptote at y equals 0, which means my graph cannot cross over this x-axis because that's y equals 0. So I have enough information to kind of tell that my graph is generally going to look like this, but I want to plug in some more points because I don't know, does my graph go up really fast and then come out like this? Is it going really slow? Like this? So I got to get some more values in there. So I'm going to evaluate the function. Let's see, I want to evaluate it at 1. I'm going to evaluate it at 2 so I can get an idea of what's happening on the right side of the graph. And I'm going to evaluate it at -1 just so I can get those points and plot them. When I'm doing these evaluations, I just want to make an XY table because it's the easiest way for me to plug in and figure out. Because remember, evaluate just means plug in for your x value. So we said we want to do -1 We already know 0 because that was our y-intercept up here. So if we wanted to, we could plug it in. We don't need to, though, because we're just trying to find some more values. Then we'll plug in 1, and we're going to plug in 2. So since my function, my f of x, is just 2 to the x, all I'm doing for each of these evaluations is replacing the x value with whatever number I'm plugging in. So for the first one, I'm getting 2 to the negative first power, which anytime I have a number to a negative exponent, I can get rid of the negative exponent by flipping the number and making the exponent positive. So then this is really just 1/2. If you forgot your exponent rules, there's a link to them on the first page of all of the virtual classrooms, just like where the unit circle was, one of those tabs says exponent rules, and you can always reference them there. So having plugged in -1, now I know I have the point -1, 1/2. When I plug in 1, I get 2 to the first power, which just gives me 2. So I have the point 1, 2. When I take 2 and plug in 2, I get 4. So I'm plotting the point 2, 4. So now I just want to go back up to my graph and plot these points. -1, 1/2. So -1, 1/2 is like here. Then I want to go 1, 2, and 2, 4. So now I can see that my function looks like this. And I know that this part is flattening out because of the asymptote. It can't go past 0. Connect the dots. And I'm done graphing my function. So your classwork today is going to ask you first to find all of these things. It'll decide if it's growth or decay, find the y-intercept, find the horizontal asymptote, evaluate the function. It's only going to ask you to evaluate the function at a specific number. But for all of these, you want to make sure when you're answering them, you're typing in the answer correctly. So your y-intercept is a coordinate. Your asymptote is always y equals. And then when you're evaluating, you only have to give me the actual value that you get when you're evaluating. So let's try one more just to make sure it really makes sense. So let's graph g of x equals 4 to the negative x. So first, we're going to say it's growth since b equals 4. But then I look at it and I notice that it's b equals 4 to the negative x. Because this x is negative, it's really saying that it's a decay graph because we're reflecting it. We can also think about it as 4 to the -1 is really 1/4. So anytime you have this negative up here, it switches your rules. So even though we immediately wanted to look at that and say it was growth since b equals 4, it's really, we don't want to be tripped up, it's really decay since b equals 4 and x is less than 0. The x value is negative. So we could also say and x is negative. So when the x is negative, it switches your rules. So since originally we would have said it was growth, it switches it because it reflects it. So it's really decay, which means our graph really should look like this. Then let's find the y-intercept. So that means I'm going to plug in 0. I want to find g of 0. So I get 4 to the -0. There's really no such thing as -0. It's just 0. 4 to the 0 is 1. So my y-intercept is 0, 1. Then I want to find my asymptote. Again, I'm not adding anything here, so my asymptote is just y equals 0. And the last thing I want to do is evaluate. So I kind of like to do steps 1, 2, and 3 right away, and then look at what I have to decide which points I want to evaluate at. So I go in, and at this point I would like to draw the graph before I go and evaluate, because I want to see what I'm working with. So I know I've got the point 0, 1, and I've got the asymptote at 0. So just like the last equation, I'm going to plug in my same numbers. I'm going to evaluate at -1 and 1, and then I'm going to decide from there if I want to try 2 and -2. I could just do both. It wouldn't hurt. More points makes it more accurate. But let's see. So if I'm going to plug in -1, I'm going to say 4 to the -1, which is really 4 to the first power, which is 4. That gives me the point -1, 4. So when I go to -1, I go up to 4. 1, 2, 3, 4. Then I want to find g of 1. When I plug in 1, I get 4 to the -1, which is really 1 over 4 because it's negative. So I have the point 1, 1/4, just like here. And I can tell from these points that my graph is clearly going like this. If I wanted to, I could plug in -2 and get a more accurate picture, but it doesn't look like I'm even going to be able to plot -2 on my coordinate grid. So I had enough points to figure out what the picture looked like from there, and I'm done with that graph.